Okay, we have another differential equation here and we are asked to solve it. So we have y prime plus 3x squared y equal to 4x squared times y squared. So assuming that you have already tried the other methods of solving differential equation but you failed to get the solution, then try to see if this given differential equation is Bernoulli's equation. Okay, so if we can find out that this is a Bernoulli equation, then we can solve it using the method that we have discussed in our previous video. Okay, first we have to compare the given equation into the standard form of Bernoulli's equation, which is given in this equation y prime plus function of x multiplied by y equal to another function of x then multiplied by y to the n. Okay? Now, if you look at closely the two equations, this one is the form of Bernoulli's equations. So they look similar. Okay? If you find out that this one is comparable to this form of Bernoulli's equation, then we just find what is p of x so that we can solve for the integrating factor, which is dependent on the value of p of x. Here the p of x is this one, which is equal to 3x squared, and then we also have to find what is q of x, which is in this case we have 4x squared as our q of x. Then our n is equal to the exponent of y here, which is equal to 2. So after that, we have to solve for our integrating factor. So the integrating factor formula is given by this I of x equal to e to the integral of quantity 1 minus n multiplied by p of x then multiplied by dx. Okay, so this is p of x. Then substituting the value, we have e to the integral of 1 minus our n is equal to 2. Then our p of x is equal to 3x squared, then multiplied by dx. So 1 minus 2 is negative 1 multiplied by 3x squared. So we have e to the integral of minus 3x squared dx. And this is equal to e to the, you put the constant outside the integral sign, so e to the minus 3 integral of x squared dx. Then using the power formula of integration, we have integral of integral of u to the n. Integral of u to the n du is simply equal to u to the n plus 1 over n plus 1. So we have to make use of this formula. Okay, so substituting, we have e to the minus 3. So this is integral of this is equal to x cubed over 3, then plus c. But we omit the plus c in this equation because we'll be having another c in our formula or in the solution of the general solution of the Bernoulli's equation later. Okay, so we'll omit that c at the moment. So we have 3 here, 3, so cancels out. So our integrating factor equal to e to the negative x to the power 3. Okay, so I will rewrite it here. Our integrating factor is e to the minus x cubed. Alright, then substituting this into our general solution. So the general solution of the Bernoulli equation is given in this form: y to the 1 minus n equal to 1 over in ix times the integral of the quantity 1 minus n times q of x times I of x dx, then plus c. So this is the general form of the solution of the Bernoulli or Bernoulli's equation. So let's just substitute the values. So we have y raised to the power 1 minus n, where n is equal to 2, okay, equal to 1 over I of x, which is equal to e to the minus x cubed, then times the integral of the quantity 1 minus n, our n is equal to 2, times q of x, where our q of x is equal to, this is our q of x. Our q of x is equal to 4, okay, this one, 4x squared, then multiplied by I of x. Okay, so our I of x is this one. This is our I of x. So substituting, we have e to the minus x cubed, then dx, then plus c. Okay, so this is now our resulting equation. So y to the power 1 minus 2 is equal to y to the minus 1 equal to, from the log exponent, so we have a log exponent x to the power, 1 over x to the power negative m. This is equal to x to the positive m. So we will apply this for this one. So we can rewrite this as e to the positive x cubed, then multiplied by, this is integral of 1 minus 2 is minus 1 times 4. So this is minus 4 x squared e to the minus x cubed dx, then plus c. Okay? Then, so our left side is equal to 1 over y. Now again, this is from this laws of exponents. So time equal to e to the x to the minus positive 3. Then put the constant outside integral sign. So we have integral of x squared e to the minus x cubed dx, then plus c. Then after that, so if you look at the given, so we can apply here the u substitution. So we have e to the u, so we can consider this as our u, e to the u, and let's find out what is our du. So if we let u be equal to minus x cubed, then we have our du equal to, so derivative of this, so this will go down, and then minus 1. So we have negative 3x squared times dx. So solving for dx, so we divide both sides by minus 3x squared. So we have du over minus 3x squared equal to dx. Now, let's replace this dx here with our dx, this one, and simplify. So we have 1 over y equal to e to the x to the power 3 times, we have minus 4 integral of x squared e to the u times dx. Our dx is du over minus 3x squared, then plus c. Then we have here the x squared at the denominator, we have x squared at the numerator, that cancels out. We have negative here, divided by negative, so that becomes positive. So 1 over y equal to e to the x cubed, then times, this is numerator, denominator, so we can rewrite this as 4 over 3 integral of e to the u du plus c. Okay, so using the formula of the integral of e to the u du, which is equal to e to the u plus c. Alright, so this is a perfect du. So we have 1 over y equal to e to the x cubed times 4 over 3. Then e to the u, integral of e to the u is simply e to the u and plus c. Then substituting the value of our u, which is our u is equal to, our u here is minus x cubed. So minus x cubed, then plus c. Okay, and then we apply the distributive property of multiplication. So distribute this and multiply. So we have 1 over y equal to e to the x cubed multiplied by, okay, so put the constant here, 4 over 3. Then we have e to the minus x cubed. Then plus c times e to the x cubed. Then again from the laws of exponents, so we can apply the laws of exponents to combine these two. So what will happen if we combine these two? So they have the same base, right? So we will make use of this formula. From the law of exponents, we have x to the power m times x to the power n is equal to x to the power m plus n. So we have to apply these laws of exponents. So this will be, they have the same base, e. Then you will just add the exponents. We have x to the 3 plus x to the, plus minus x to the 3. And plus c times e to the x to the 3. So we have the rows in combining. We have x cubed plus negative x cubed. So this is just equal to 0. So in other words, this is just equal to 0. Okay? So you have another laws of exponent that, okay, before that, so we have 1 over y equal to 4 over 3 e to the 0 plus c e to the x cubed. So e to the 0, another laws of exponents, e to the, or if you have x to the 0 is equal to 1. So the same way, e to the 0 is equal to 1, provided that x here not equal to 0. That's the condition, but for sure this base here, which is e, is not equal to 0. That is why it's very sure that this is equal to 1, because e is 2.7182818. Okay, so we have passed this condition. Alright, so this is just equal to 1. So 1 over y equal to 4 over 3, then plus c times e to the x cubed. Okay, so this can be your answer, or we can simplify this. 1 over y equal to, find the LCD here, which is equal to 3. So this becomes 4, and plus, this is understood over 1. So 3 divided by 1 is 3. And times the numerator, we have 3c e to the x cubed. And then you just flip this, or cross multiply, or we just flip, no? From the, it's up to you how will you manage this. You can solve for y here. You cross multiply, and then divide both sides by, then you will get this y equal to 3 over 4 plus 3c, then e to the x cubed. So this is our other expression. Okay, although it's already okay here. If your exam is a multiple choice, then perhaps this is the one of the choices, or maybe this one. So you should know how to manage your result. Or it can be like this, because this is already okay. Or if you're asked to really express y in terms of the others, or other variables or constants, then you have to use this answer. Okay, so that's all. I hope that you were able to follow our explanation and our discussions. If you have any questions, then you may leave your question or message in the comment section below. Thank you.